Hello students, good morning. In last lecture we have discussed about the way a AC circuit is connected to resistance. Now in this lecture we will discuss about the AC circuit connected to inductor. Fate will give the supply of AC to the inductor. Then we can say that suppose this is an inductor, a coil, and this coil is connected to the AC supply. Here we can show a key to close or open the circuit. Then when this key is closed, when this key is closed, the current starts to flow through this circuit. I is the current passing through this circuit. Here is the inductance of this coil. This is the AC supply. This is the symbol of AC supply. Now we can say that this is the AC circuit connected to inductor. When the current flows through this circuit, when key is closed, then current I begins to grow in inductor due to the magnetic flux linked with the coil also changes, and induced EMF produced EMF opposes the EMF supplied by the AC. That is, when current flows through this circuit, as current goes on increases, then the magnetic flux linked with these coils also changes, and due to change in magnetic flux, EMF or opposite EMF induces in this coil, and this EMF induced in this coil opposes the supply EMF or the EMF of this AC supply, and therefore we can say that this we know that by Lenz's law, we can say by Lenz's law, we know that the EMF induced in the coil E is equal to minus L into di by dt. That is, we can say that the EMF induced in the coil is given by the equation E is equal to minus L into di by dt, where this di by dt is the rate of change of current, and this L is the inductance of the coil, and this di by dt is the rate of change of current. Now, to maintain the flow of current in the circuit, this applied EMF must be equal to the induced EMF. That is, from the Kirchoff's law, we can say that by Kirchoff's law, we know that the EMF, that is, we can say that the EMF induced in the coil can be say that by E dash, and applied EMF can be given by the E. Therefore, total EMF in the closed circuit is equal to 0, or also we can say that E is equal to E dash. E is equal to E dash, or we can say E is minus E dash. E plus E dash is equal to 0. By Kirchoff's law, E plus E dash is equal to 0. Therefore, E is equal to minus E dash. We can put the value of E dash in this equation. Therefore, we will get this minus sign will be remain as it is, and this E dash, that is induced EMF, is equal to minus L into di by dt. Minus L into di by dt. And therefore, we can say that this will minus minus will cancel, and therefore this will equal to L into di by dt. From this we can write di is equal to this di is equal to, when we take this L on the left side, then it will be go in di is equal to E by L into dt. Now integrating this equation, integrating above equation, we get, when we integrate this equation, we can write here integration of di is equal to integration of E upon L into dt. Now integrating this above equation on both sides, we get di is equal to E is equal to integration of di is equal to integration of E upon L into dt. Now we know that E is equal to, this E is equal to E naught sin omega t. E is equal to E naught sin omega t. L will be as it is, and this dt will be as it is, and this integration of dr. Now when we integrate this dr, we get this I is equal to E naught sin omega t. We have to take this E naught divided by L outside the integration. Therefore, we can take as this, and taking integration of sin omega t into dt. The integration of sin omega t, or we can say that the mathematical formula, that is integration of sin x is equal to minus cos x, and when we take this the constant term, then we can suppose there is a sin 2x, then we take the integration of sin 2x as like the minus cos 2x divided by 2. Therefore, we can write here this minus will be here, then cos omega t divided by omega. Integration of sin omega t is equal to minus cos omega t divided by omega. Or also we can take as this type, if you sin integration of sin omega t is equal to cos omega t divided by this omega here. Now we can write the constant of integration can be taken here plus c. C is the constant of integration. Therefore, we can write I is equal to E naught upon L in bracket minus cos omega t divided by omega. Now, the cos omega t, we know that the cos x is equal to sin of pi by 2 minus x. We can use this formula here. This equation, take this minus side outside the bracket, this omega L. Cos x is equal to Sin pi by 2 minus, yes, we can use this formula here, and therefore we can write here sin of pi by 2 minus omega t. Sin of pi by 2 minus omega t. Multiplying this minus sign to this bracket, then we get E naught upon omega L. Then sin of omega t minus pi by 2. Omega t minus pi by 2. Therefore, we get I is equal to E naught upon omega L sin of omega t minus pi by 2. This I is equal to. Now we can write here I is equal to I naught sin. This I is equal to I naught sin omega t. Here I naught is equal to, take this I naught is equal to E naught upon omega into L. Here we use this I naught instead of E naught upon omega L. Therefore I naught is equal to E naught upon omega L, where I naught is the peak value of current. This I naught is peak value of current, and this gives the alternating current. This E naught is the peak value of EMF. L is the inductance of the coil. Now, comparing equation, when we compare this equation with the equation number first and this last equation, I lags behind the alternating voltage of EMF E by the phase angle of pi by 2. When we compare this equation with the equation I is equal to I naught sin omega t, or E is equal to E naught sin omega t. When we compare this equation I is equal to I naught sin omega t minus pi by 2 with the equation E is equal to E naught sin omega t. Then from these two equations we know equation E is equal to E naught sin omega t. This equation and this equation, when we compare these two equations, then we can say that the alternating voltage E or alternating current I lags behind. We can say this equation number suppose 2, and already we have written the equation number 1, or we can say here from equation 1, this equation 1. Comparing equation 1 and 2, then I, that is alternating current, I lags behind E by pi by 2. From these two equations, we can say that here is a minus pi by 2 in this equation. Therefore, I lags behind E by pi by 2. And therefore, when we take the phasor diagram, here we can draw the phasor diagram of alternating current and alternating EMF. Then we get the diagram as this type. Here we can take omega t on x-axis, and here we can write E or I on the y-axis. We are taking E and I both on the y-axis, and omega t is on the x-axis. And when we draw a diagram for EMF and current, then we can say at when E time or phase difference is 0, then we have already drawn the graphical representation of EMF. This is the peak value of EMF. This is the graph for EMF AC. And current lags behind pi by 2, and therefore we can draw this diagram as this type. Current is always less than EMF, therefore the graph, that is maximum amplitude of the graph, will be less as compared to the EMF. Draw dotted line for the current, and therefore we get as this type of graphical representation for the I. This is AC current. Here the angle will pi. This is 2 pi. This is pi by 2. Therefore, here is a phase difference of pi by 2 between the E and I. That is current I lags behind the E by the pi by 2, and maximum amplitude of here, the graph of I is less than that of the EMF. It is always less, and therefore we take as this type. This is maximum EMF. This plus E here. This is the maximum EMF minus E, and this is the maximum current inducer. That is, we can say this is I naught plus, and here this is the maximum current in negative region, that is minus I naught. And this is the graph of E and I versus omega t. Graph of E and I versus omega t. From this graph, we can say that the current I is lags behind the EMF E. From this graph, we can say that there is a phase difference of pi by 2 between the graph E and I. And therefore, we can draw the phasor diagram for this EMF and current. We can write diagram, phasor diagram. Here we can write the E. This is E naught, maximum E naught. This is the phasor diagram of current I. From this graph, we can say that there is a phase angle of pi by 2 in between the maximum EMF and maximum current. We can say this is the phasor diagram. We can write here this I is equal to I naught sine of omega t minus pi by 2, and this is equal to E naught sine omega t This is the phasor diagram. Phasor diagram for purely inductor. We have already discussed about the phasor diagram for resistance. When AC circuit is connected to the resistance, and this is the phasor diagram for purely inductor. When this inductor is connected to the AC circuit, we can draw this type of phasor diagram, different type of phasor diagram for the different components. Here we can observe the angle of this angle must be pi by 2 between E naught or maximum EMF and maximum current. This angle is omega t, and the angle between E and R is 90 degree, or we can say that pi by 2. And here the current is lags behind the EMF, and therefore the current lags behind. This is EMF which is in ahead of I, and this I is lags behind the EMF E by angle of pi by 2. Therefore, if you compare this equation, when we compare, we have already written E is equal to E naught upon R, and this I naught is equal to E naught upon R, and I naught is equal to E naught upon omega L. This is the equation for the resistance. When we compare this equation, suppose equation A and equation B, then when we compare these two equations, we can say that the R is equal to omega into L. R is equal to omega into L. That is, omega L represent the effective resistance offered by the inductance of inductance L, and this is called the inductive resistance. This inductive resistance also can be written as inductive resistance. This inductive resistance can be written as XL is equal to omega into L. XL is equal to omega L. Or also we can write here omega is equal to 2 pi f. Therefore we can write here 2 pi f into L. This omega L represent the inductive resistance. Therefore this inductive resistance is indicated by the XL, and therefore XL is equal to omega into L. Omega is equal to 2 pi f, and therefore we can write here 2 pi f into L. That is inductive resistance. The function of this inductive resistance is similar to that of the resistance in purely resistive circuit. That is, when we connect the resistance to AC circuit, then the resistance offered by the AC circuit, that is, we say that R, and when the inductor is connected to the AC circuit, then resistance offered by the AC circuit is given by the XA, and that is called as the inductive resistance, and this is given by this equation. XL is equal to omega L is equal to 2 pi f into L, and it is directly proportional to the inductance L and the frequency of the alternating current. This resistance, from this equation we can say that this resistance is directly proportional to inductance of the coil and the frequency of the AC circuit. Here 2 and 5 are constant. Therefore XL depends upon the frequency and inductance. Okay, thank you.
Nomor ini